Fun fact, developers are not paid engineers.
Thank you.
Okay, let's begin because I need to get a nap in before happy hour. Fun story. So I was supposed to be here at probably 10:30 last night. My flight didn't get until about 2:30 in the morning. So I just literally hacked this presentation throughout the day while I was like mingling with folks. Anyways, the motivation for this talk is that a lot of you are developers. Put your hand up if you're a developer. Have any of you actually taken anything to production before? And going to Vercel does not count. Okay, so the reason for my talk is really to help you understand some of the actual inner workings of trying to take something to production. And it's not just about, hey, I'm going to take my repo and my app that I built and point it to Vercel or Netlify, and then boom, it's on its way. There's so much behind the scenes that we don't get to see that I build on a daily basis that you're going to get a little bit of the taste of, and also try to understand a little bit of the networking. But anyways, my name is Marino Wijay. I am a solutions architect at a company called Kong. I also am a tech lead at a company called Empathy Ops that I also own that does a little bit of advocacy and consulting. You can find me on the interwebs, virtualize.wtf. Go find me on the blue skies. Our agenda for today is pretty basic. I want to talk about how we deploy to production because, like I just said, you could take your Git repo and drop it into some sort of system and it'll be on its way. But when you actually have to productionize this in the enterprise, that story changes a lot, especially when you have to wrap around compliance, when you have to wrap around policy, when you actually have to answer to shareholders, different ballgame altogether. So when you decide you want to enhance your user experience, sometimes you'll find that using something like Netlify will limit you. And that's not a bad thing. It's just you start to realize that you need more customizations, you need a larger team, you need someone else to actually manage the lifecycle of your application, and you can't just simply push the prod. But there's some networking basics behind that, and I want to cover a little bit of that as well as a little bit about what we do with APIs, because I think everyone works with APIs here. You also build APIs, but there's a lot of magic behind it that, I wish I could cover in like 25 minutes, but I can't. My watch is not working. Why am I even looking at it? Anyways, okay, so deploying to production. So one of the things that developers do really well is they build fantastic applications, which means they generate something called packets. Because guess what? That data needs to move around a network. It needs to go somewhere. Someone's accessing it, and so we have networks that back it. But then guess who's left dealing with that problem? Me. People like me, people who deal with infrastructure, who have to manage it and scale it. And the more applications you build, you begin to realize that it becomes very challenging to build a single service network for all those kinds of applications. I'll give you an example. The application you run on localhost here is going to be different than the application you run somewhere in, let's say, Kubernetes on AWS or GCP. So can you all go to this QR code for a second?
Oh, you open that. Sorry.
Security folks won't do it. That's totally fine. And then whoever pulled out their phone, yes, let me know when you can access the link.
Doesn't go.
Why doesn't it go?
Safari can't open the page because it can't connect to
It works on my computer though, right? I can show you. Hold on. See, hold on. There we go. It works. Hey, why is it? Anyways, so it's a lot more. It's a lot more than just pushing the local host and running a Docker image on your system. There's so much wrapping that goes around that we don't actually see it, and we're not supposed to see it because for a developer, we don't have to care about networking, but it's always nice to know what's happening behind the scenes. So I broke it down in a few ways, right? What happened? There we go. Okay. So I broke it down in a few ways. Most developers will go straight to that SaaS platform. Well, they'll pick Vercel, they'll pick Netlify. AWS Amplify is a great example. A lot of people might be using it because guess what? You drop your code and output is the application that you want to use and sell and maybe make money off of and build an ARR or an MRR or whatever it is. And then that's the ship it fast mentality, right? But what happens when you begin to scale up to 1,000 users and you begin to realize that your app that you built can't handle those users. And so you have to scale. But then you realize, well, fly.io doesn't allow you to scale very easily. Like you can't just jump in and be like, hey, give me 100 nodes. Now I can handle all those incoming connections. Boom, I've solved that problem. It's a lot more than that. And so now you've realized I need a team to manage this application. So I'm going to send it off to another team to manage the infrastructure, the platform by which my application will run on top of. So they might be using something like Heroku or DigitalOcean's app platform or Google Cloud Run or something, which still gives them a little bit more control, because then you can specify, things like, hey, I'm going to store my environment variables in the secrets manager, and then I'm going to also use an external database, and I'm going to size the database according to my needs, but I still don't have to think about the infrastructure and the networking behind it. And that's great, because for the majority of needs, this works pretty well. When you become really big and global, and when you actually have teams that have to come in here, review the systems and the applications that you need to move into production, chances are you're doing it yourself, or you're using some sort of infrastructure as a service like Kubernetes on Amazon or Google or even Sivo. You're actually figuring out all the plumbing. That's a lot of work, but that's a lot of control. Yes, it's a lot of complexity, but now you can actually see the wiring. When you can actually see the wiring behind your house and you get to choose how you want that electrical to look, you can actually wire up some really cool lighting in your home. But then when you just offload that to someone else to do, you kind of just see the wall. You don't know what's actually happening behind the scenes. And I've seen nightmares before where maybe any one of these SaaS platforms, there might be like some like nefarious stuff going on behind the scenes. I don't want to talk about it, but the reality is, I don't know if all of these platforms are truly battle tested for production at scale. And so you have to think about that when you're really moving into enterprise grade production. So I'm a developer. I want to make this super easy. I'm going to build an application, test it out. Localhost works fine. I'm going to push it to Git, and then I'm going to push it to a cloud provider, and I'm going to be on my way. But one of the problems with this is that we don't have peer review. We don't have a team that comes in to assess the change management process. Change management means something in our organization is going to change and impact the rest of the organization, either in a positive or negative manner, but we need to be ready for that. And this little flowchart here doesn't account for that. It doesn't account for peer review. It doesn't account for approvals. It's just fire away, ship fast, and move on. But this model does. It actually allows you to build your application, test it, have some peers review it, go back to the drawing board because something is actually broken, fix it. Now it goes through a compliance review because someone's going to realize, hey, you're missing some firewall policies. You're also missing some authorization policies. You're not using TLS or security or encryption between your requests. Fix that. Once you fixed it, the necessary policies get wrapped around, and then you can move it into production. But a lot of this is process oriented. This is this concept of policy as code, where someone has said, I want you to make sure you have these guardrails in place, codify it somehow. But that's just developer speak, right? Here's what actually happens behind the scenes. Someone is sitting there putting these building blocks together to make sure it all works for you. So while you're building that little app that's going to run and say hello world whenever you query it, someone else has to sit behind the scenes and manage all of that. It's a lot. It's a lot to remember. It's a lot to know. It's a lot of moving pieces. Sometimes you have more control, sometimes you have less control. And it kind of ties back to that earlier diagram I was talking about. But this is the life we live as infrastructure operators. We support the apps that you deploy, but there's a lot of networking behind it too. Let's talk about the networking. Okay, so this is a packet. I'm not going to get into it. You should care about this part right here. This is what you've actually put in there. It's your data, it's your payload. But everything atop of that, everything that's darker blue, that's me. I got to make sure I deliver your data somewhere. So I got to create the roads, the laneways. What's that? Yeah, it's a packet. It's TCP/IP, but I have to make sure that I can find that connection, terminate it, and make sure the data gets across the wire or across the road. Don't worry too much about it, but understand that this is the complexity that networking folks get into, or even infrastructure teams get into. And then here's another lens of it. Like, this is the OSI model and the TCP/IP model broken down, where you actually have your developers, that focus on that top layer, and then everything below it, I have to think about. I have to think about the wire that might be broken in my data center that is causing link flappage, which is probably causing latency in your application, but you don't see that. I do. I only catch that because you told me something is wrong with your application. You blame the network. When you blame the network, guess what? I'm going to go dig in. I'm going to find out what's wrong. But I have, what's that?
It's always TMS.
Yes and no, and sometimes, right?
Never the network though. It was the cable.
It was the cable, right? So there's a lot of shared responsibility in this particular model alone. In fact, like network teams, operational teams, DevOps people, platform engineers, they play at that level too, at that layer that you're all working on, the ones where you're developing your applications. But here's also another view of that, right? There's all these different tools. This is a Kubernetes view, by the way. This is like my view, my perspective. There are tools that you'll use, systems that you'll piece together in a bigger puzzle that supports the developer's application. Why? I want it secure. I want it to scale. I want it to make it more money. I also want to be able to iterate faster and move quickly into production without having to think too much about refactoring or rebuilding the entire damn thing from scratch. That's what all of this is there to support. Now, this can look different, right? You could use different implementations, different technologies to make this possible. And this will always change over the years. Now, let's talk about encapsulation for a second, because I want to take us to like what a developer should think about for a second. Everything's ones and zeros. Everything's electrical signals, but that gets translated into something of text, of data. And so we start off with this binary, right? We're sending the stream of ones and zeros, and they hit something called a switch. We're not gonna get into a switch, but a switch is just a local area network, which has to connect to other local area networks. So we use something called a router to bridge that connection. And then we have these frames that move around that get encapsulated in something called packets. How many of you know what an IP address is? Yes, a number of you, right? That's what we tend to deal in, right? Every one of you has a phone number. Everyone, you don't have a phone number? Okay. I don't know how you deal with your 2FA, but that phone number is so valuable. But guess what? No one's going to remember my phone number. Right? We remember names, though, and we have an address book. We'll talk about the address book in a second. But that address book is very important to us to help us identify who is who. And then once we've gotten to that level of identification, we get to figure out how to get to that destination. So let's think about IP addresses for a second. There are a few kinds of IP addresses that live out in the wild. There are private IPs, which you've all got them in your home routers. I guarantee you, you're lying to me if you do not have them. And then there's local hosts, which we've kind of seen a little bit of. If you've ever played in the cloud, though, you'll notice that when you spin up a virtual machine instance, it tends to have a public IP address because you're just going to connect to it through the public internet, and you'll use some like authentication, either username, password, or if you're actually much more secure, an actual certificate to authenticate into your instance versus like just trying to do this the half-assed way. But these public IPs are important because they're so limited. In fact, phone numbers are actually limited. And what ends up happening when we actually have to create a new set of phone numbers, we need a new area code, right? I've seen this happen so many times in Toronto, it's just mind-blowing. We have like 647, 416, 905, 289, a whole bunch of others that I can't even remember now. And that's why it's just good to have names. But those area codes are kind of indicative of where the location is. That's kind of how IP addresses work, right? We have this first bit of information in that IP address that tells us where something is, like generally speaking, globally speaking. Maybe it could be some part of the world. And then the rest of that becomes very specific as to maybe our postal code or our zip code as to the actual neighborhood. And then we'll get specific with the house number, right? Which is the last octet that you see there. 33 is the house number of some particular network. But it's indicative of an endpoint. We're actually connecting to something. Something owns an address, and we're going to talk to it. So each one of you has a phone and a laptop. You're likely going to have two addresses. And to communicate amongst all of y'all over the digital internet or whatever, you're going to use those addresses, except you're not going to remember them. You're not even going to remember the names. Your systems just automatically connect to just things that it's very familiar with and remembers. And then anything else you don't know, you'll just go to google.com and then probably search it up, and then you'll find the answer pretty quickly. Let's follow the packet for a second. So pretend each one of these is an application and a desktop or a client that needs to access an application. what ends up happening is within a local area network, one little network, this node 1 can talk to node 2 pretty easily because it knows about it. There's this concept of a broadcast where everyone's talking to everyone else in this little confined network. Now, for a small network, that's fine. 10 nodes, no problem. 1,000 nodes, that's a problem because you have all these different people trying to communicate with each other. This is why we have groups. If we break things down into groups, which is the concept of subnetting, then we cut back on this crosstalk communication. It's not so noisy. But at the same time, if we still need to talk to someone in another group, we use a concept of a router. Now, the concept of a router is, hey, we need this one individual to find us a path to get to this other individual. Guess what? Danny Thompson is our human router. So we may live in different parts of the world, but he brought us together with commit your code. Right? Okay. It's always DNS. Now you've gotten past the phone number stage, right? Now you're trying to like remember if someone texted you the other day, you forgot to take down their name, you only have their number. They didn't even it's not even very indicative of what that conversation is. There's no names in the conversation. You're like, who the hell is this? What did I say to them? Why did I send them a picture of like whatever it was? Anyways, so that address book is pretty important. We have this concept of A records, which is a name to a number, right? I'm going to create a name, some name, it could be commityourcode.com, and there's going to be a number behind it or an IP address behind it. And then we'll have the reverse. I know the number, but I don't have the name, so I'm going to define a name for it. So I have a PTR record. And then I might have something called a CNAME, which is a nickname or a name of names. So I might be going to the Dallas conference, and there might be only one DallasConference.com, and that redirects to commityourcode.com. That's what a CNAME does. And then we have your address book, which I'm sure a lot of you have ever played with this technology called Route 53. That is an address book. That is a DNS server, which just maintains everything that you connect to. So as developers, these are the kinds of building blocks you probably don't even see. You might interact with DNS addresses and host names, but I'll tell you what you actually interact with, not the bigger picture. Your app is like this little thing, this little box that needs to kind of traverse this massive network that you don't even know about. But what you're all after is APIs, right? You just want an API. You want to connect to an API. You want to authenticate to an API. You want to tell an API, I want you to do this for me, and then give me information back. So what is an API? An API is just an endpoint, which you can manipulate. You can run CRUD style operations. You can create. What does the R stand for? Read. There you go. That's like the easiest thing too. You can update. You can delete resources. But you can control how you do this. You can actually use proxy technology or reverse proxy technology to control that. But these APIs are what you build and what actually allows you to communicate with other APIs. So I'm going to build a technology, an application, but guess what? I don't want to build the other parts. So I'm going to go talk to the OpenAI API. I'm going to talk to the Google Maps API to get me map data because I want to build my own version of Pokemon Go with AI. Maybe, I don't know. But at the end of the day, that API translates to a host name, which is a DNS address. Commit sins, or I don't know why I put that. I was not thinking when I wrote this presentation literally 3 hours ago. Should have been commit your code, but I was thinking of something completely different. Commitsins.com/portal. Portal is your API endpoint. There might be other endpoints like back there that we don't know about, but this might be the only one that's exposed that we can interact with, we can capture data from, we can write to, we can take and integrate into our own code so that let's say we're running an application or a for loop, output the information of what that portal's supposed to tell me, and then if there's something of a match, then we can use that data for something else. But this translates into an IP address, which is networking. So you all are actually doing networking if you didn't realize it. Yeah, right? Okay, so I'm actually at the end, and I think I'm doing really good for time. I don't know why there's a phone here. I don't know whose phone that is. But let's think of this flow of an API for a second, so we can kind of see the pieces fitting together. I am a client with a web browser, or I've got a terminal that I run a curl request, or I have an application that's making an API call out to something. So I have to hit an API. I've named several, whatever you want. It could be the AWS API because you want to deploy infrastructure, because guess what? You can do that in a very programmatic sense. So I hit the API, but I also have to translate that to a DNS readable address, because once I get that IP address, I need to route to it because it's not going to be on my local network. But once I route to it, now I know I can get to commityourcode.com conference. I can get there because my browser just made the API call for me. That's all I did. But we are building that commit your code. Who's hosting it? Do we know? I don't know. I'm actually asking you. Yum's hosting commit your code, like the website?
Oh, no.
Okay, that's what I'm trying to figure out. We can actually figure this out if we really want. You think it's Google Cloud? Okay, let's actually figure this out. Do we have a few minutes to kind of hack away and figure out where this is? Okay, all right. Okay. By the way, I don't know what happened. Summary quickly before I show up the terminal. Going to prod is not easy, right? You can definitely use SaaS-based services out there that actually get you what you want, but when you need to productionize it and enterprise it and run compliance around it, something like the SaaS offerings that you have out there get you to a starting point, but they're not the complete solution. It's all networking, we know that. Devs love APIs. Okay, let's go take a look at something. So I'm going to open up my terminal here, right? And I'm going to full screen it. And hackers love APIs because sometimes APIs are not locked down and it's very easy to just scan and see what endpoints are available. Okay, so I'm going to run a command called dig on commityourcode.com, and I'm just going to do the short flag here. So that dig command gives me 2 IP addresses. What that's telling me is both of those addresses are responding. That means there's load balancing going on. If for whatever reason, one node in one location hosting commityourcode.com went down, the other node will answer for it. So I've always got availability. This is an interesting one here. But who owns these IPs? So what I do, and maybe I might find out this information. I have no idea. I might get lucky. I'm going to take this IP and we're going to go into Google and we're going to just look this up. Who owns this IP? I'm just going to search for a website, and let's just drop in an IP address. Look up Amazon. Oh, interesting. So it's possible that Danny, when he built this website, or the team that built this website, might have used Firebase, or sorry, not Firebase, Amplify. Google has Firebase, right? Yes. So they might have used Amplify to be able to do this, or they could be using Beanstalk, Elastic Beanstalk, or maybe Danny is like this super ultra Kubernetes platform engineer and he's running this on EKS and we just don't know. But if you actually think about it, that's actually how we get to find out where things are hosted. This doesn't really definitively tell us anything, to be honest, though. It just tells me that, hey, it's running on Amazon. That's about it. But if anyone was curious about like why this networking stuff is important, when you actually build for the enterprise, you know what we're actually building for? Making sure that our investors don't lose money. That's what we're really building for. And I bring that up because when you think about applications that are actually truly built out there, the moment something goes offline, a business is losing money, right? Business is losing a ton of money. Guess what? Who's getting the call? The CEO is getting the call from the investors. What the heck's going on? How do we fix this? And then that kickstarts an initiative internally to do an investigation. Why did this fail? How do we prevent this from happening? And then the cycle gets kicked off to essentially make sure that the application never goes offline again. And that is how you take localhost to production. I probably left a whole bunch of stuff out there. I'm so sorry. We only had 25 minutes. I would love to talk to you about like databases and stuff like that, but I know nothing about it. So thank you all for coming to my talk. If you have any questions, do not ask them. No, I'm kidding. No. If you have any questions, feel free to ask them. Okay.